Hey everybody, this is Larry, this is me going Q4 of the weekly contest 357, maximum elegance of a K-length subsequence. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this problem. So this one I found very hard. I took about 20 minutes, I was very proud of myself, so if you watch the live portion of it afterwards, I was very proud that I got it because I did not find this to be easy at all. That said, there are a lot of hints in terms of that you get from experience that you kind of get and feel it out. I often talk about the texture of a problem, and it's just about, as you kind of feel out the problem, how, if with enough experience, you're able to really grasp at the solution or like the possible solutions, right? The first thing, of course, is to look at constraints. I'm just talking about how I kind of arrived at this and maybe a way for you to kind of arrive at if you're given the thing, right? So n goes to 10 to the fifth, and k is less than or equal to n. Immediately, what this says to me is that n times k algorithm is too slow, and at that time, that means that I don't even have to consider any n times k algorithms because they're just going to be too slow, right? For example, maybe there is a dynamic programming n times k. Josh mentioned somewhere that there is, but I didn't even have to think about it, right? Because it's whether it exists or not, it doesn't matter. It's too slow. So the way that I thought about it is that, okay, in that case, the thing that felt a little bit close to me is some sort of sorting and greedy and sweep liney algorithm. I think this part is actually, if you are able to jump ahead, or after we kind of talk about it, watch me solve it live. I actually break it down how I do it, but yeah. And I was saying this on stream, which is that, well, you may ask, Larry, how do you know that it is greedy and all this stuff, right? And the idea, to be honest, I did not know per se. I couldn't prove it. I wouldn't say couldn't prove it, but immediately I didn't have a proof in my head. The reason why I did it was, to be frank, it is just the universe of things I know, right? Meaning, if it uses like fancy pants algorithm, maybe some algorithm that's named after some really famous mathematician or whatever, and I just didn't know it, well, there's no way I was going to come up with a contest or an interview or whatever anyway, right? Like, it is what it is. The die is cast. I can only know what I know. So if that's the case, I can't do it. So the only way that... So in so to get better, you have to build up the size of the universe of things that you do know, so that hopefully maybe one of them is true. And that's basically my thing, is that I'm like, okay, well, maybe I have this sweep line idea, and the complexity would fit. You have an n log n maybe, or something like this, and n is big but not too big. The n log n should be good enough, and I'm trying to think about different sweep lines, and there are only a couple possibility that, it's not the easy thing to trace through, but it is possible. For example, you can maybe do and the idea behind these problems is that, in a way, it is brute force, but not that brute force, right? It is a way to do search, but taking advantage of greedy to eliminate a lot of possibilities, right? Meaning that you eliminate things that are impossible, so you only kind of search amongst candidates that are way more efficient than brute force, right? And a lot of that, from experience, it's just about how do you say it? It's about having some kind of because you don't have enough time to do anything after sorting, so you're basically treating each element after sorting or some ordered structure. You can only do log n time of work, so you have to be able to build off previous work that you've done, similar to dynamic programming, if you will, but not the states and stuff is not quite the same. But it's that idea of okay, I've done this much work, I want to do this a little bit more incremental work that kind of updates the work that we've done, so that we have another locally maximal or minimal or locally optimal solution that we could build off. And in that way, is greedy, right? Hopefully, you're still following so far. And initially, I was thinking, okay, there are only a couple of possibilities. I've said that a few times. And what do I mean by that? What I mean by that is that, okay, let's say we have, so we start with K. There are only a couple of dimensions, right? So let's say we have start with K, and I did this during the contest. I was like, what if we start with K is equal to 1? Can we build a K is equal to 2 answer, K is equal to 3 answer off that, and so forth, right? Of course, the answer is kind of yes, but I couldn't figure out how to do it efficiently. Like it ended up, like optimistically, and I don't even think that's true. I had an n times ke lower bound solution, but as we said, that's too slow. And then I thought, okay, what if you look at this formula, total profit plus categories distinct square, and I was like, okay, what if we start with one distinct category, right? That's kind of easy. You just kind of take the max out of all these categories up to k items or whatever, right? And then can you build two distinct categories based on that? And I was like, I didn't really know how to combine them, because in a way, then now you're taking k elements and you have k, or you have to take k elements, so you're taking like k minus I elements from one and I elements from another, or something like this, and it can't do it in log n or log k or log whatever time, right? Like it's just too slow. Even if I do have a good, like it's lower, like the lower bound of that, even if I was able to kind of find a data structure or whatever to fit all the criteria, is too slow. So then I kind of dismissed it, not that quickly, but just like in my head, right? And then I thought, okay, what if we start with total profit is max, and then distinct categories slowly going up? And then I kind of just thought it through, and I was like, oh, that makes sense, so let's do it that way. And that's basically how I did it. And to be clear, even at that point, I didn't have to code, but I was just like, I think I can do this in a quick enough time, right? That fits the performance that we need. So, and then I said, okay, let's say, so here, initially, let's just say we have total profit, maximize total profit. What does that mean? That means that we just take the K max profit elements, and then the distinct categories it'll be what it is, right? Because it's just like depends on your top K elements and how many distinct categories there are, right? So then now you have this current local max that is a function of profit and categories. Then what does that mean? That means that now if you sort it by profit as we did, that means that when you do a scan line, when you go from left to right, the profit has to go down, right? Because you're saying, okay, let's say I have this number that wants to get in here. By definition, it will go down, or equal, I guess, if you want to be more precise. So it'll be equal or lower, right? So the only way that could give you a better possible answer is if it gives you an additional distinct category, right? Meaning that the total profit goes down, distinct category has to go up for you to have a better possible answer. And kind of that's basically the general framework that I was like, okay, that makes sense. Let me start coding it and then figure it out. And that part you could watch the live portion, because I actually, you could even see me being like, oh, I don't know exactly like all the branches of if statements. So let me just like write down what it means to me. So yeah, so as we said, we sort by the, we don't even care about the sorting by categories. We just sort by the profit. So then I kind of wrote this part in a really funky way, but another way to think about it is that, let me rewrite this then. So if count is less than K, then total, right? Scene is re-added to a category, or then if category not in scene, then we add it. Otherwise, we add it to this heap thing. And I didn't really do it this way yet, right? And then else, after we have enough items, we say, okay, if we have things that we want to remove, then we do this thing, right? I'll re-explain it. I think I kind of muck around the code and it's kind of a little bit confusing. Give me a second. Let me also make sure that this is correct first, because that's just awkward if this ends up being like I had a typo and copy and paste. Oh no, I did have a typo and copy and paste. Oh. Yeah. Well, I got it right the first time with my other logic, but I think I tried to clean up the code without thinking about the branches. I kind of rushed it a little bit, so my fault. But this should be easier to read, so that's why I did it. It's not just because I was like, oh, whatever. Right? So the idea is that, okay, like we said, the first K items, we just kind of add it to the profit, and then we also just kind of keep track of where it was seen. This part here is kind of, actually I removed the comment by accident, but it's just basically the thought process here is that, okay, let's say, okay, let's just jump ahead a second, right? Let's go here. Let's say we're past the first K items, and now we have an item that we want to add to, that we want to consider as a candidate. What happens, right? So as we said, the total profit goes down, the number of categories go up. So if the number of categories do not go up, then that means that the distinct category square portion doesn't change, and so it never makes sense for you to swap it out. So if category is not in scene, you could just move on. Or if you already have it in the existing group, you could just move on, right? So that's something that you can do. Otherwise, you want to find out which ones of the things that like of the group that is the first K or top K, we want to see which one can we remove. Well, so by definition, maybe definition is not the right word, but you also want to make sure that the distinct categories don't go down, right? So the only way the number of distinct categories goes down is if you remove the last element of that category. So basically what I try to do is, okay, in a greedy kind of way, you always want to keep, for each category, the max element of that category that exists, right? So then, for the second max, or in lower, second max, or the min if you want to, so basically maybe the min and the second min, all the way to the second to last min, we want to consider replacing it if the replacement allow us to create a new category. So that's basically the idea. And the way that we do that is with a min heap, because we're always trying to remove the min element, right? And that's what I have here, is that the biggest element, here the biggest element, we don't have to consider it, and we add it in the category. If it is seen, and because we already sorted by profit, the second element that we've seen, we have to maybe delete it in the future, replaced with a different item or whatever it's called, right? Yeah. And then now, if we have a new category and we want to see if we want to use it, well, then we take a look to see how what happens if we remove it. We add it in and we remove an item from a category that already exists. So that's basically the idea. We remove the smallest element, so in a greedy kind of way, you want to replace the smallest element with and actually technically the profit, the existing profit is going to be smaller than X because that's what you sorted on or equal to. But now you have a new category, so that's the thing that we're trying to balance. And then now you're like, okay, there's more, so maybe we can possibly go that way, and that's pretty much it. The complexity here is this is n log n, and of course the heap on every item is going to be at most log n here. So everything is n log n, and that's pretty much it. And oh yeah, after every item, I guess after k, but the total is the total profit, and of course this is the distinct category scoring function. So you just want to see, okay, is this now the new best? And that's pretty much it. That's all I have for this one. Let me know what you think. Let me know if you have any questions. It's definitely a way tricky, way tough, greedy. And like I said, I kind of YOLO. I wouldn't say YOLO, but I had good confidence that I could implement it. And it was one of those things where if this wasn't right, like if these greedy properties don't hold up, I probably don't know how to solve it. So I was just like, this is the only thing I know that to do. So I kind of just gave it a shot. I mean, there's some instinct that like felt right, but like it's hard to do proofs during a contest, especially for greedy things. So yeah, that's all I have for this one. Let me know what you think, and you could watch me solve it live during the contest now. 78 is pretty okay, considering I had a really slow Q2. Oh, and they fixed the timing. Alright. Alright, so far only behind 6 people. Times 2 maybe. Okay. Length N and then integer K. Man, that's the only sentence I've read. So like not focused. Profit and category, okay. Let's define the elegance, sure, why not? Of a subsequence of items is total profit plus distinct category square. I guess total profit is pretty self-explanatory. Oh, they actually explain it though. Yeah, good for them. Let's maximize maximum elegance from all subsequences of size k in items. What does that mean? Oh, of all subsequences of size k. Oh, okay. So amongst all subsequences of size k, find the maximum. Okay, fine. And then they write it again. Like there's these 2 sentences are like waste of time. Or one of them is redundant. Maybe not. I don't know. Maybe I just do 2. There's some subtle thing there. And then they define subsequence. Okay, as long as I know it's not a subarray. Okay, so we have k. Let's look at constraints. N is pretty big. Okay, so none of these, not a easy obvious DP type thing. Maybe, or or at least not the obvious one. Maybe this is still DP. Okay, so k is equal to 2. We pick 2, and then elegance is total profit plus distinct categories. What does that mean? It doesn't mean, what it doesn't mean is that things have to be distinct. It's just that you don't get enough for it necessarily. This is a tricky one, which is why I guess only 6 people got in so far. Maybe a little bit more now. Alright, focus now. You don't have to look at the leaderboard every 5 minutes, or less than that even. How would I even approach it? How do I do a greedy? Also sneaky like type, right? Yeah, long for some reason. Like I'm in Python, but just kind of. It's a greedy sorting problem, maybe, is my instinct, but I don't necessarily know. Or like heap, maybe, but feels like sorting and like whatchamacallit, scan line, but what does that mean? Okay, so can you do a DP on K? No, that's still too slow. Because then we have to do an update. And it's not clear that you want to maximize the number of distinct things, or the maximum number of distinct things is not necessarily the maximal answer. Okay. Can I walk it up? For k is equal to 1, it should be obvious. And then what happens when k is equal to 2? K is equal to 2. Is is 2dp. Oh, like a back heap type thing. For, can I do it for, okay, one distinct thing. One distinct thing should be easy. And then two distinct thing, what does that mean? We have to do like some combination or something? That seems awkward. Subsequence, okay. Or is it something I have not considered? No, I mean, it's not greedy in the sense that greedy will give me the answer. It's some sort of greedy way to do a brute force of sorts. But what is the brute force dimension? Distinct categories? One distinct category is easy. Two distinct is how do you choose the maximal 2 buckets? And then also keep doing it. And that's a tough decision. I don't think that really makes sense. Looks like Larry is not sleeping early tonight. If I'm given a, can I do? Okay, let's say I do greedy on total profit and then get replace it with another item with a smaller profit. Then you have to remove say I have a heap, what does that mean? That means that I remove something that is of another color or whatever. But does that even make sense? Well, right now the profit would be optimal. The total profit part will be keep maximized, and then I have a set of things that we do and we replace, but would that lead to a local maxima or whatever? We get stuck on a local solution. Okay, so let's say you replace a thing. If that category is already in there, you ignore it because that you can get a better answer from that. Yeah. If you get a new distinct category, what do you remove? You also don't want to lose a color or category or whatever. So do you just like a second bag of extra things? It seems so greedy, I can't prove it though, but I'm going to YOLO it just because I don't think I have any idea otherwise. I don't know if this is even necessary, but what am I doing? I'm sorting by, and I guess the second part doesn't actually matter. Okay, so that's slightly improved it. Okay, and then now, okay, you know how to do this, Larry. I mean, well, you know how to implement this. Whether it's right or not is another story. Or maybe just do it in for what was it called? Profit category in items. Yeah, so okay, so 0 total is equal to, I guess, 0. This C is right. Okay, here we want to say I think this is kind of crappy, but okay, right. So if category not in scene, then if this is a new type of item, we want to remove. Man, this is awkward. Let me just write it out in English. We remove the cheapest item that does not, that has a duplicate category. If category is in scene, then what do? Then we remove the cheapest. No, you don't do anything. You just go, because if we already seen it, and that the count is less than whatever, because otherwise we just keep on adding. The count part is a little bit awkward for sure. Okay, then basically L count is less than K, then we just add it anyway. I mean, this should do nothing. It's a useless no op, but that's fine. otherwise, and I know that I have to get a heap otherwise. So if it's not seen, okay, that means I have to keep track of things. Okay, so that means that this is awkward. We add it, and this is the only time. Is that true? Where we added to let's go and consider print profit or it's a heap, Larry. Do we want a min heap? Yes we do. Yes we do. Okay. Okay, so that means that this is a duplicate thing. Otherwise we move the cheapest thing. Oh, this is also obviously also just totally wrong. Okay. Okay, so that means that otherwise you never want to replace because you're just replacing something that's cheaper. So okay. If length of week, what's on top again? Oh, just the profit. So then now we will remove the top. We don't even care about it. Well, actually we do care about it because we have to add it to total. And because it's not in scene, then now and are we Gucci? Wait, some of this isn't a real. I think this is more correct, but what did I say this is again? That means that we are swapping, otherwise we don't care. Okay. Well, that's unfortunate. What am I doing wrong? The category is not going to be in scene. Oh, because consider is greater than 0. Oh, we have to do silly Larry. We don't even care about that yet. If count is greater, less than. Okay, I kind of wrote this in a weird way. Okay, less than k, and scene dot add category at the very least. Is that it? Yeah, because it's not a duplicate, we don't add it to the heap for consideration. Okay. 1650. Okay, well, at least we got answers. Not the correct one, but you know, you can't have everything, I guess. I mean, these are easy to debug in theory. Am I just like bad at math? How do you even get 16 if you want to? 16 is, was it 2 squared for 12? You can't even get, I think I'm just like bad at math somewhere. Okay, so let's just, total scene, okay. I feel like, if this isn't correct, I have no idea to be honest, but okay. Printing is hard. Okay, so because of this contain you, we don't update. Okay, that's more accurate, I guess, precise, as they say. Well, okay, that's a little suboptimal. Oh, I don't know. No, these cannot be right because that's less than k. Also, we don't increment k because I don't know. Don't know why. Don't know why. Okay. Alright, 17, 19, 7. Alright, it just turns out that I'm really bad at doing the very basic things of incrementing. Let's see. 17, 19, 1, 7. At least it's good for the input, the examples. Woohoo! Actually, I'm proud of this one. Because I think this one's kind of tricky. To kind of, I don't know. I consider it tricky. I don't know if it actually is. Thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about these problems and this problem and all the explanation. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.